Okay, here we go. Uh, I wrote them down. I'm going to tape them to the wall because I might be referring to them over the next couple of days. It's a little hard for me to read it because as I look at the screen while it's recording, everything is backwards. And then once it goes through editing, it reverses itself. But it says here elements will be zero, right? Um, Single ions will be. Oh, I'm trying to read it backwards through the paper. Single ions, that means an ion by itself, not like two of them paired together. Single ions will be their charge. So if you have Fe positive 3 written, it's positive 3. Compounds will sum to 0, they add up to 0. A polyatomic ion within a compound will sum to its charge. So like if you have H2SO4, SO4 is a polyatomic ion, it's negative 2, it will sum to negative 2, and that should not change the overall charge for the compound, which should be 0. And I'll probably do a problem or two on that tomorrow. And then the second page that I'm going to post, I actually think I'm going to tape this one up right away to finish the problem that I ended with. Okay. Group 1 elements are positive 1, always, no exceptions. Group 2 elements are positive 2, always, no exceptions. Fluorine will be negative 1, no exceptions. These are the rules for in compounds. And then hydrogen is usually positive 1, oxygen is usually negative 2, and we have that binary ionic compound or the IDE rule. We use that for the groups. 15 is negative 3, 16 is negative 2, 17 is negative 1. And remember that IDE rule refers to the last or second element in a binary compound. All right, I'm going to tape this up. I think I got myself some tape here. Okay, so there are my rules. Hopefully it's visible. All right, and now I'm going to do that last problem, as I said. All right, we have N and H. Now, usually the second one in the compound is going to be the negative one. Uh, as I was mentioning, as I got cut off before, and then I had to go to a department meeting on Zoom, and then I didn't have time to finish this up and repost it. That's why I'm posting it late. I apologize for posting the second half late. I usually try and get everything up by 10 o'clock. But N isn't the second one, but it's the first one, but it's still going to be the negative because the NHs and the CHs, those compound classifications are exception to the rule. But even when we look at this, this kind of helps us out. All right, the nitrogen rule is down here. The hydrogen rule is here. Hydrogen's above nitrogen. Nitrogen group 15. So we're going to put hydrogen first and say, even though it's written second in the compound, this is an exception. Okay, it's positive 1 since it has to equal 0 because it's compound. Here, nitrogen's going to be negative 3. Hydrogen's positive 1. So that's not the answer. Remember, we're doing number 10 on page 161, which is about the hydrogen. Now we get up to the next one, okay? We have KH, which was our problem, right? Here, look, K is in group 1. The group 1 rule comes before the hydrogen rule. Since the group 1 rule comes before the hydrogen rule, okay, potassium is going to be positive 1, hydrogen's negative 1. Now when you do the summation, you get 0. That's why hydrogen's negative 1. And it is negative. It's the second one. It's an IDE. We would actually call this potassium hydride. In HCl, right, H is positive 1, Cl is negative 1. It actually follows the binary rule. Group 17 is negative 1. And for water, plus 1 for hydrogen, because hydrogen comes before oxygen. And then oxygen does turn out to be a negative 2, as it normally is, but doesn't have to be. And I'm just going to do one more problem with you. I know I'd say I was going to keep it under 5 minutes, but just one more minute. I'm going to do one more problem. By the way, the answer for that one was number 2. I'm also going to do the problem H2O2 and show you the the importance of the hierarchy. Actually, I'm going to race and do a little higher. Last problem, I promise. I usually try and keep these things in total to like 20 to 25 minutes because I know there's probably pausing, stopping stuff like this. Going back to the H2O2, all right? The hydrogen rule is before the oxygen rule. Since hydrogen is before oxygen, I'm going to put a positive 1 for hydrogen. There's 2 of them making positive 2. So to make this equal 0, oxygen has to be negative 2. And you say, oh, oxygen's negative 2. Yeah, that's what it's supposed to be. But there's 2 oxygens. So each oxygen is a negative 1. And when oxygen is a negative 1, we call it peroxide. So this is hydrogen peroxide. Yes, the same stuff that you may have in your bathroom. Okay, this turned out to be just over 6 minutes. I apologize for that. Have a great day. We'll be back at it tomorrow. Bye-bye.